Here's another example that came off an old diploma exam. In an automobile collision, the severity of the injury to the driver can be reduced by an airbag. In a car initially traveling at 100 kilometers per hour, note the units, kilometers per hour, the airbag stops a 62 kilogram driver in 90 milliseconds. Determine the magnitude of the average force exerted by the airbag on the driver. Let me kind of explain this situation before we start to pick it apart. In a collision, there's no other force that would stop you on an airbag except for the force of the airbag. Like, there isn't anything else that's going to act on you. The force of the airbag would try to stop that inertia or that velocity that you would be traveling forward into the dash of the car. The airbag saves you from A, going into the dash of the car, or B, getting ejected from the car due to that collision. So the force that's being applied by the airbag is the only force on or in this example. That's why we don't have to worry about any other forces, net forces. So first thing I'm going to do is look at this velocity. We have an initial velocity here equal to 100 kilometers per 1 hour. I'm going to do some dimensional analysis to change this to meters per second. You may remember the quick conversion, but I'm going to do that the long way anyway, just to remind you. Well, to change kilometers to meters, we know that there are 1,000 meters in 1 kilometer. So that gets rid of my kilometer units. There are 60 minutes in 1 hour. So I get rid of my hour units. And 1 minute is equal to 60 seconds. So when I look at my units, my kilometers will divide out, my hours will divide out, my minutes will divide out, just like we did in one of our earlier exercises. And we will go 100 times 1,000 divide by 60 times 60, which is 3,600, and you should end up with an initial velocity of 27.78 meters per second. We have a final velocity here, because it stops the driver, of 0 meters per second. We have to put these in the proper units before you put them into the formula. So we have VF, we have VI. We now can figure out our change in velocity. We also know that we have the change in time that this took place, 90 milliseconds, which is 90 times 10 to the negative 3 seconds. And we have the mass of the driver, 62.0 kilograms. So because we're looking for force, we can start with that impulse formula. Force change in time equals mass times change in velocity. We have everything in here. This thing goes, or the driver of the car goes from 27.78 meters per second to 0 in the collision. We have the change in time. We're looking for force. So force in this case will be equal to mass times change in velocity divided by change in time. Put our numbers in. Mass of the driver, 62.0 kilograms. The change in velocity, we go from 27.78 to 0. So we have a change in velocity of 27.78. meters per second. And the change in time here is going to be 90 times 10 to the negative 3 seconds. If we put all those numbers in, punch them in on our calculator just to confirm that that answer is right. 62 times our previous answer we just worked out, divided by 90 times 10 to the negative 3. You should get 1.9135, or if you wrote this to the proper significant digits, 2 significant digits. 1.9 times 10 to the negative, to the positive 4 newtons. Now, I just want to talk about something quickly before we end this example. Remember that the driver is traveling in one direction when the car gets into a collision. The driver's heading towards the front dash. The airbag is going to apply the force in the opposite direction. So some people may describe that force as negative, or if there was a direction on this question, you would have to say that the force was opposing the driver's motion in this case. Even though that the question is just asking for magnitude, be careful if you're being asked for direction, because the airbag applies the force in the opposite direction. That's why airbags save lives, is because the force is in the opposite direction. So this question only wants magnitude, but what you'll see in example 3 is that I will have to include a sign in here because the force is opposing the motion of the object. You have to take care of it. So some people tend to put the velocity in as negative to realize that the force opposes the motion.